So hello, very good evening to all. Right. So in this class, basically, we are going to do some numerical, right, related to general organic chemistry. So in this, we will try to solve some questions related to GOC, and this question consists of both, NEET and IIT both questions, right? So this is going to be a very interesting class. So all of you just join. Yeah, good. Right? So this is a problem solving on GOC, right? In this, we are going to solve a question related to inductive effect, electromagnetic effect, hyperconjugation, and also try to solve question related to the carbocation and carboanion, right? Now, so the first question, as we see, this question comes in NEET 2023, right? So the question is assertion reason, a statement-wise question, right? So in this statement, one is given. So in an organic compound, the inductive and the electromagnetic effect operates in opposite direction, right? So according to this question, statement one state that in an organic compound, when inductive and electromagnetic effect operate in the opposite direction, the inductive effect predominate. So whether this statement is true or false, right? And the statement second is hyperconjugation is observed in orthoxylene. So in the light of the above statements, choose the correct answer, right? So you have to choose the correct option, whether the statement one is true or statement two is true or vice versa, right? Chalo. So let's see the statement one in a detailed way. In statement one, state that in organic compound, when the inductive and electromagnetic, right, when both inductive effect, whether it is a minus I effect or a plus I effect, or minus E effect or plus E effect, electro effect, when they are acting, which predominates. So always remember, beta, whenever we talk about inductive and electromagnetic effect, always it's not necessary that inductive effect dominate, right? Because inductive effect is no, this is an effect shown by the compound which having the more withdrawing group attached, then they show minus I effect. When the donating group is attached, then they are shown by the plus I effect. So this is not the correct statement, that is the inductive effect predominant. Always remember electromagnetic effect dominates, right? Now the second one is hyperconjugation is observed in orthoxylene. So let me draw the structure of orthoxylene, right? So the structure of orthoxylene like this, that is, this is CH3 and this is again CH3. That is 1,1,2 dimethyl benzene. So this is also known as a orthoxylene. So hyperconjugation. Obviously hyperconjugation is observed in orthoxylene because it consists of H3H here. So we can say that this statement is absolutely correct. So which option is correct, beta? That is statement one is false, but statement 2 is true. So this is the correct one, right? Chalo. Move to the next question. So the next question is, that is the number of sigma and pi bonds. So you have to calculate the number of sigma and pi bond, number of sigma bond, pi bond, and lone pair of electron in pyridine, right? So all you need to calculate these three values: sigma bond first of all, then pi bonds, and then lone pair. So you need to calculate all these three values. So let me first draw the structure of pyridine, right? So what is the structure of pyridine, beta? So the structure of pyridine is like this, right? So this is the structure of pyridine. Mm, let me erase this little bit. Okay. So the structure of pyridine be like, here we have one N. They having the lone pair. Right, rest all are same, like just like the benzene. So here we have a double bond. Again, we have a double bond. Right, and here also we have a double bond. So this is in a structure of pyridine. So we know this all carbon having one hydrogen here, one hydrogen here, one hydrogen here, and one hydrogen here. So this is a structure of pyridine. So let me calculate the first of sigma bond, right? So let's calculate the number of sigma bond first. So in this, the number of sigma bond is like we have carbon hydrogen, that is 1, 2, 3, 4, 5. So 5, and that is a 6, 7, 8, 9, 10, 11. 11. So total number of sigma bond is 11. So 11 sigma bond. We all know na sigma bond means single bond, right? Since single bond, we have only one sigma bond. So the number of sigma bond is 11. Similarly, number of pi bonds. So we have a three pi bond. One is here, one is here, and one is here. Only three pi bonds in this pyramid structure. Na? So we can say that number of pi bond is 3. Now you have to calculate the lone pair. So what is the number of lone pair, beta? So here we get only one lone pair, right? So lone pair is 1. So the correct answer is 11, 3 and 1. Right? So which option is correct? That is option B. I hope सबको समझ आ गया होगा ये. Everyone got it? सबको समझ आया किस तरीके से हम लोगों ने सिग्मा और पाई बॉन्ड निकाला पायरिडिन के अंदर. सो हमने सबसे पहले पायरिडिन का स्ट्रक्चर देखा और फिर हमने बहुत इजीली कैलकुलेट कर लिया. सबको पता है व्हाट इज सिग्मा बॉन्ड. सिग्मा बॉन्ड किसके बीच होता है? हमेशा सिंगल बॉन्ड. जब भी सिंगल बॉन्ड होगा तो वो हम लोग का सिग्मा बॉन्ड कहलाता है. तो हमने देखा यहाँ पे कितना सिंगल बॉन्ड है, तो 11 है. उसके बाद से तीन पाई बॉन्ड दिखे तो पाई बॉन्ड 3 हो गया और लोन पेयर तो एक ही दिख रहा है. तो इसीलिए आंसर क्या हो गया? 11, 3 एंड 1. चलो, मूव टू द नेक्स्ट क्वेश्चन बेटा. दैट इज कंसीडर द कंपाउंड और स्पीसीज. तो आपको इनको देखना है एंड यू हैव टू कैलकुलेट द नंबर ऑफ कंपाउंड स्पीसीज विच ओबे हकल्स रूल. जो इसमें से हकल्स रूल को ओबे करेंगे. ठीक है. सो यू हैव टू फाइंड दोज कंपाउंड और स्पीसीज विच ओबे हकल्स रूल. राइट. दिस इज यू नीड टू कैलकुलेट द नंबर ऑफ कंपाउंड और स्पीसीज विच ओबे हकल्स रूल. Right. So we know that what is Huckel rule. Can anyone tell me what is Huckel rule for aromaticity? Hmm? So according to Huckel's rule, so according to the Huckel's rule, the formula for finding the Huckel rule is equal to nothing but 4n plus 2 pi. So 4n plus 2 pi electrons. So अगर जो भी इस रूल को फॉलो करता है, that is 4n plus 2 pi electrons, then they are said to be aromatic, right? Then they are said to be aromatic. Okay. So out of these, which of the following will follow this, right? So consider the following species and you have to identify the number of compound species which obey Huckel's rule. जो इस rule को obey करे, right? So first, take the example of first one. So here we have 1, 2, 3, 4, and 5, right? So if you want to calculate the number of pi electron for this, so we can say that this one first, and the next one is second, okay, and next is fifth, and 7, right, and 7. So they will follow Huckel's rule, right? They will follow Huckel's rule. So when you solve this, you'll get to know that is 4n plus 2 pi electrons. So we can say that this 4n plus 2, right? 4n plus 2. In this, we can say that 1, 2, 3, 4, and 5. So number of 5 electron, number of pi electron is 5. So we can say that 4n plus 2 is equal to 10. So 4n is equal to 10 minus 2, that is 8. So we can say that 4n, or we say n is equal to 8 by 4, that is 2. So whenever n is come like 0, 1, 2, 3, or we say 4, then we can say that it will follow Huckel's rule. Okay, so like this only. For example, in second case, they are not following the Huckel's rule. Why? Because they came to know 4n plus 2 is equal to 4. So this is 4n is equal to 4 minus 2, which is equal to 2. So then this is 4n is equal to 2, so n is equal to 2 by 4, that is 1 by 2. So this is not possible, right? Value must be come in 0, 1, 2, 3, not in a fraction. So we can say that only the compound 1, 3, 5th, and 7. So 1, 3, 5th, and 7. So that is 4. So total number of that is 4. So 4 compound or species obey Huckel's rule. Okay, move to the next question. That is given below are the two statements. So again, this is the statement based question. So one is level at assertion and other is level at reason. So we have a two such statement. One is known as assertion and another is known as reason. So assertion, that is chlorine is an electron withdrawing group, but it is an ortho para directing in an electrophilic aromatic substitution. Right. So they are saying chlorine is an electron withdrawing group. So they are saying if we have benzene and chlorine group is attached to this. So we all know this chlorine is a electron withdrawing group. So chlorine is an electron withdrawing group, but it is an ortho para directing group in electrophilic substitution. So is this true? Yes, it is definitely true. Why? Because in chlorine they having three lone pairs. So due to this lone pair, they take part in resonance, and due to the resonance, here resonance dominate over the I effect, right? So that's why they are orthopara directing group because they having lone pair of electron and which takes place participate due to resonance, right? So the assertion is absolutely correct. That is electron. Chlorine is an electron withdrawing group. Even it is an orthopara directing group in a electrophilic substitution reaction. Now, what is the reason for this? So, reason is that is inductive effect of chlorine destabilize the intermediate carbocation formed during the electrophilic substitution. However, due to the more pronounced resonance effect, the halogen stabilize the carbocation at ortho position. Right. So, this is not the correct reason for this. Right. The correct assertion is absolutely correct, but the reason is not up to the mark. So, we can say that A is correct, but R is not correct. समझ आया सबको? Because we all know chlorine is an electron withdrawing group, but why they behave like a ortho para directing group in electrophilic substitution reaction? So it is basically due to presence of this lone pair of electron, and due to this they take place in the resonance. They participate through a resonance. So due to the resonance, they show ortho para directing group and increase the electron density at all ortho and para position. ठीक है? चलो. Move to the next question, beta. That is, what is the hybridization shown by C1 and C2 carbons respectively in the given compound? So we have in a given compound, right? So we have in a given compound like this, and they want us to find what is the hybridization shown by C1 and C2 carbon respectively in the given compound. So we have a structure like this, OH, this is C, CH, CH, and this is CH2, CO, O, CH3, right? And they ask what is the hybridization shown by the C1 and C2 carbon. So which one is the C1 and C2 carbon? Can anyone tell me? Right. So we know that while IUPC naming the priority group is which is the priority group, because here we have a three group, right? We have a CHO group, that is an aldehyde group. So here we have an aldehyde group. Here we have an ethene group, that is alkene, and here we have ester group. So we know the priority order for naming is ester, right? So priority order is like the priority order is like COOR first, right? Then comes alkene and CHO. So this is the priority order. So numbering will start from the ester side. So this is the first carbon we have, carbon number 1, and this is number 2, this is 3, this is 4, and this is 5. So in this question, they're asking what is the hybridization shown by the C1 and C2 carbon. So C1 and C2 carbon, you need to calculate the hybridization for this, right? You need to calculate the hybridization for the C1 and C2 carbon, respectively, in the given compound. So let me find out this, that what is the hybridization shown by the C1 and C2 carbon. So here we can say that C and C1, the hybridization. How will you calculate hybridization? So hybridization is nothing but this is equal to number of sigma bond plus lone pair of electron plus lone pair of electron. ठीक है. So here the number of sigma bond is like we have one sigma bond, two sigma bond, and three sigma bond. So the number of sigma bond is like three, right? So number of sigma bond is equal to three, no lone pair. So it comes out to be sp2. So hybridization is sp2 for the first carbon, huh? C1. Now let's calculate for the second one, that is C2. So in C2, we have a number of sigma bond is equal to 2, which H1 is 2 with the two other carbons. So that is 4 plus 0. So the hybridization will be like sp3. So what is the hybridization for C1 and C2? That is sp2 and sp3. So which option is correct, beta? B. So I hope everyone got it, huh? That is B option is correct. सबको समझ आ गया होगा कि बी ऑप्शन कैसे करेक्ट है, बिकॉज इसमें पूछा था हाइब्रिडाइजेशन, कि हाइब्रिडाइजेशन क्या शो करेगा C1 and C2 कार्बन, एंड दे आर नॉट मेंशनिंग व्हिच वन इज अ C1 and which one is a C2. So you have to find first which carbon is called C1 and which carbon is called C2. And how will you find? By looking at the functional group priority order, because while naming we all know this thing, remember this thing, that while naming, if more than one functional group is present, then which functional group is treated as a priority basis and which will take as a substitute, right? So whenever ester and aldehyde and alkene are present, give priority to ester group, right? So by doing this, we can able to calculate the C1 and C2. And once we know which one is C1 and C2, then we can easily calculate the hybridization. Okay? Sure. Now, the next question is, what is the correct IUPAC name of the following compound? So, please, all of you try to find out the IUPAC name of the following compound. This is very easy question, we can say that. What is the correct IUPAC name of the following compound? Right, so you need to remember the some basic formula, the how will you name the carbon, huh? Where from the numbering is started, always contain the chain which is longest in nature, or which contain the functional group. So we have a two option, either we'll start numbering from here, that is 1, 2, 3, 4, 5, and 6, or we'll start from here, that is 1, 2, 3, 4, 5, or 6. So can anyone tell me which one is the correct one? Which one is the correct one for numbering? Anyone? Anyone tell me? From where we'll start the numbering? Hmm? If we start the numbering from here, then 1, 2, 3, then alcohol will come on the number 3. And if the substitute, right? For example, if we start the numbering from here, then we have a then we have a locant, like in 1 we have one bromo attached, then 1, 2, 3, then 3 we have one hydroxy group, then 1, 2, 3, 4, 4 and 5. Then 4 and 5 we have a substitute. So this is a locate when you calculate from this side, numbering from this side. Now same, if you done numbering from this, then you have a locate, get the locate like this, that is 2. Then 1, 2, 3. Then we have 3. Then we have 4. Then we have 5, 6, right? So the lowest set of locant rule. We all know this thing now. We always use the lowest set of locant rule. So this is the correct one. This is not the correct, because here we have 1. Here we have 2. So the correct locant is this one. So we'll name this from this side only. So let me quickly write the correct side by which we name the compound. ठीक है, सो समझ आ गया ना सबको कि किस तरीके से हम लोग को नंबरिंग करनी है. ऑलवेज सेलेक्ट द लोवेस्ट लोकेंट रूट, राइट? लोवेस्ट लोकेंट मतलब जिधर से सब्स्टिट्यूट पहले आते हो उसको सेलेक्ट करना है. तो चलो देख लेते हैं फटाफट. तो ये हो गया हम लोगों का 1, ये हो जाएगा 2, ये हो जाएगा 3, ये हो जाएगा 4, ये हो जाएगा 5, ये हो जाएगा 6। सो हमें पता लग गया सबसे बड़ा क्या है, 6 कार्बन का चेन है, यानी ये तो होने वाला है हेक्स, राइट। और इन भी होने वाला है, तो हेक्सेन हो गया। और कोई फंक्शनल ग्रुप लगा है क्या, ऑल लगा है, तो ये हो गया हेक्सेनॉल। तो ये तो क्लियर हो गया बिल्कुल कि ये हेक्सेनॉल होने वाला है। नाउ अब सब्स्टिट्यूट का बारी आता है कि सब्स्टिट्यूट कैसे लिखोगे। सो इन वन वी हैव अ ब्रोमो, एंड फोर वी हैव अ मिथाइल, एंड फाइव वी हैव अ क्लोरो। सो अगर अल्फाबेटिकल देखो तो सबसे पहले एबीसीडी में क्या आता है, ब्रोमो। सो यू कैन राइट एज वन ब्रोमो, वन ब्रोमो, राइट। देन वन ब्रोमो के बाद क्या आएगा, फोर मिथाइल या फाइव क्लोरो। सो ऑब्वियसली फाइव क्लोरो, क्योंकि एबीसीडी में क्लोरो पहले आता है। तो दिस इज फाइव क्लोरो, फाइव क्लोरो, एंड देन फोर मिथाइल। फिर क्या आएगा आपका, फोर मिथाइल। सो वन ब्रोमो, फाइव क्लोरो, फोर मिथाइल, हेक्सेन ऑल। सो विच ऑप्शन इज करेक्ट बेटा, दैट इज वन ब्रोमो, फाइव क्लोरो, फोर मिथाइल, हेक्सेन। एंड कितने पे ऑल है ये तो बताओ, थ्री पे ऑल है। कितने पे ऑल है, थ्री, तो हेक्सेन थ्री ऑल। सो विच ऑप्शन इज करेक्ट, दैट इज ऑप्शन ए। सो ऑप्शन ए इज एब्सोल्युटली करेक्ट फॉर दिस। आई होप आ गया होगा सबको समझ में ये। चलो, मूव टू द नेक्स्ट क्वेश्चन बेटा, दैट इज डाइहेड्रल एंगल ऑफ लीस्ट स्टेबल कॉन्फर ऑफ इथेन इज। ठीक है, तो आपको डाइहेड्रल एंगल बताना है लीस्ट stable conformation of ethane, right? So we all know this thing. Let me draw the structure as well. For eclipse and staggered, we have a two conformation. So eclipse conformation is the always least stable, always remember. So first of all, you need to know there is a concept behind this. So let me explain this, the basic concept, right? So you all know that ethane, hmm, ethane, ethane having two conformation. ठीक है, so ethane having two conformation, one is known as eclipsed, and another one is known as staggered. ठीक है, so ethane having the two conformation, eclipse and staggered. Always remember this eclipsed form is the least stable, because in this question dihedral angle of least stable they are asking, and they are asking from the eclipse form. So the eclipse are the least stable. They are least stable, and this is most stable, most stable. So in this question they are asking about the eclipse only, right? Because they are asking dihedral angle of the least stable. So let me draw the diagram for this. So we have a eclipsed form like this, right? Here we have one H, another one H. ठीक है, and here we have another one H, and here we have H, right? So in eclipse form, dihedral angle is 0 degree. So we can say that there is no angle between these two, right? So the dihedral angle. So dihedral angle is 0 degree. कितना है? 0 degree. So here the dihedral angle is 0 degree. Similarly, in case of the staggered form, so let me draw the diagram for staggered form as well. So in case of a staggered form, the diagram is like this. We have a three hydrogen, one, two, and three, and one is here, one is here, and one is here. So here the dihedral angle is 60 degree. So here the dihedral angle is 60 degree. So if the question asks dihedral angle of the most stable conformation, then the correct answer is 60 degree. If the question asks the dihedral angle of the least stable is eclipse form, and eclipse form the angle is 0 degree, right? So which of the following is the correct option? That is 0 degree. This one. So this is absolutely correct answer for this. So I hope you got it. समझ आ गया होगा सबको? Hmm? Right? Done? Chalo. Move to the next question. That is, a tertiary butyl carbocation is more stable than the secondary butyl carbocation because of which of the following reasons? So they are asking why the tertiary butyl carbocation is much more stable as compared to the secondary butyl carbocation. What is the reason behind this? So we all know this. Let me draw the diagram first, then we are going to discuss the correct answer for this, right? So if you draw the tertiary butyl carbocation, so we have a structure like this, CH3, C, again we have CH3, CH3, and they having the positive charge, right? So CH3, CH3, this is a called tert butyl carbocation, tert butyl carbocation. Similarly, let me draw the structure of secondary butyl carbocation. So this is a structure of secondary butyl carbocation, right? So we have a CH plus CH2 and this is CH3. So this is a tertiary butyl carbocation and this is secondary butyl carbocation. ठीक है? तो tertiary butyl carbocation and tertiary butyl carbocation. ठीक है? चलो. So this is the tertiary one and this is the secondary one. Now the question asks why tertiary butyl carbocation is more stable. So tertiary butyl carbocation is more stable because if you're considering the alpha carbon, so this is alpha carbon, and this is also alpha carbon. So in alpha carbon total we have a 3 3 3 3. That is a 9 alpha hydrogen. So 9 alpha hydrogen atom. Got it. So in a tertiary butyl carbocation, we have a 9 alpha hydrogen atom, where in this case, this is an alpha carbon, this is also an alpha carbon. So we have only 5. So we have only 5 alpha hydrogen. Okay. So in case of the secondary carbocation, we have only 5 alpha hydrogen. But in case of the tertiary carbocation, we have a 9 alpha hydrogen atom. And more the number of alpha hydrogen atom, more will be the hyperconjugation effect. Hence, more will be the stability of the carbocation. Right? If someone ask why tertiary carbocation is more stable, why secondary carbocation is more stable. So the correct reason behind this hyperconjugation, right? So the correct answer is hyperconjugation because more the alpha hydrogen atom, more in the hyperconjugation effect and more in the stability, right? So hyperconjugation play a exclusive role here in determining the stability of the following carbocation. समझ आया सबको? चलो. Next is which of the following molecule represent the order of hybridization like sp2, then sp, then sp, then sp? So we have total 4 carbon. So out of this, you need to calculate the sp2, sp2, sp, sp. So generally, we know that whenever we have a single bond, the hybridization is like sp3. In case of double bond, the hybridization is sp2. Similarly, in case of triple bond, the hybridization is like sp. Okay, so we have a 3 kind of hybridization sp3, sp2, and sp. So look at carefully. In this, they are asking sp2. So obviously, they having the double bond. So they are supposed to show sp2, sp2, then sp and sp. So let us discuss this thing. For example, if you're considering this example, that is option B, right? So let me calculate this for this. So we have CH2. So let me draw the open structure for this. CH2, double bond C, H, C, triple bond C, and here we have H. So this is the open structure of the B, right? Now let me calculate. This is a carbon number 1, 2, 3, and 4. So for carbon number 1, the hybridization is like number of sigma bond. So we have 1, 2, and 3 sigma bond and 0 lone pair. So we can say that the hybridization is sp2. Similarly, for the C2 atom, we have 1, 2, and 3. 3 only and 0 lone pair. So again, this is sp2. For carbon 3, we have 1, 2. So only 2 sigma bond, right? Because in triple bond, 2 pi bond is present now. Only 1 sigma bond is present. So only 1 sigma bond is present. So 1 and 1, 2. So 2 plus 0 lone pair. It means they having sp. Similarly, in C4, so we have C4, 3 plus 3, matlab triple bond means 2 pi bond and 1 sigma bond. So only 2 plus 0. That is again sp. So in this question, they're asking sp2, sp2, sp and sp. So correct option is B. समझ आया कैसे हुआ बी? क्योंकि बी में हाइब्रिडाइजेशन क्या है सबका sp2, sp2, sp एंड sp. सो ये सबसे आसान तरीका होता है हाइब्रिडाइजेशन निकालने का. जब भी तुमसे कोई पूछे कि हाइब्रिडाइजेशन निकालना, ऑलवेज यूज दिस रूल, दैट इज नंबर ऑफ सिग्मा बॉन्ड प्लस लोन पेयर ऑफ इलेक्ट्रॉन्स, राइट? एंड in triple bond we have only one sigma bond. In double bond we have only one sigma bond, and in single bond we have sigma bond only, right? So always remember, in triple bond we have a two pi bonds and one sigma bond only. In double bond also we have one pi bond and one sigma bond. So this is what we need to calculate, right? So they are asking which of the following represent this hybridization. So the correct option is B. Now move to the next question. That is the correct statement regarding the electrophile. So you need to calculate the correct statement regarding the electrophile. That what is an electrophile basically, beta? So we all know this thing. Anything which have a electron deficiency or they behave as a Lewis acid, right? So Lewis acid, they are also known as Lewis acid, or we say they having an electron deficiency. Electron deficiency. So anything which have electron deficiency or they act as a Lewis acid, they are called electrophile. Means electrophile are electron deficient compound and they having the strong tendency to attract to those compound having having lone pair of electron or having more electrons, right? So electrophile is negatively charged? No, because negatively charged are nucleophile. They have a deficiency of electron now, then how they become negatively charged? Negatively charged means they have an excess of electron, which is not true for the electrophile. So option A is absolutely incorrect. Now, next, electrophiles are generally neutral species. ठीक है? Electrophiles are generally neutral species and can form a bond by accepting a pair of electron from a nucleophile. So बोल रहा है कि electrophiles are generally neutral species. क्या electrophile neutral species होता है? And can form a bond by accepting a pair of electron from the nucleophile. और कह रहा है कि बॉन्ड बना लेगा एक्सेप्ट करके पेयर ऑफ इलेक्ट्रॉन फ्रॉम द न्यूक्लियोफाइल. सो ये भी सही नहीं लग रहा है. नेक्स्ट, इलेक्ट्रोफाइल कैन बी आइदर न्यूट्रली और पॉजिटिवली. यस, ये सही है कि जो अपना इलेक्ट्रोफाइल होता है वो न्यूट्रल तो हो सकता है लेकिन पॉजिटिवली भी हो सकता है. तो इलेक्ट्रोफाइल कैन बी आइदर न्यूट्रल और पॉजिटिवली चार्ज स्पीसीज एंड form a bond by accepting a pair of electron from the nucleophile. So ये ऑप्शन जो ऑप्शन सी है वो बिल्कुल करेक्ट है. बी भी सही था लेकिन वहां पे उसने सिर्फ न्यूट्रल स्पीसीज के बारे में बात करा था, पॉजिटिव के बारे में बात नहीं किया था. तो इलेक्ट्रोफाइल कैन बी आइदर न्यूट्रल और पॉजिटिव चार्ज स्पीसीज and can form a bond by accepting a pair of electron from the nucleus. Now, the last option is electrophile is negatively charged species. तो negatively charged पर nucleophile होते हैं, ठीक है? So this is not correct. So which is the correct option बेटा? C. तो C बिल्कुल ही correct option है हमारा इस क्वेश्चन के लिए. Now you need to write the IUPAC name of the compound. चलो फटाफट जल्दी से लिखो. इसमें कौन कौन सा ग्रुप है मुझे ये बताओ पहले. So we have an aldehyde group here, we have a ketone group here, and we have an alkene group here. So out of aldehyde and ketone and alkene, किसको preference दोगे? What is the order of priority in case of aldehyde, ketone and alkene, right? So क्या होगा priority का order बेटा? Always remember, CHO will give priority then C double bond O, right? So always remember this thing. Out of ketone and aldehyde, aldehyde will be given as a priority as a functional group. So numbering will start from which side? 1, 2, 3, and if you start from here, then 1, 2, 3, 4. So the better to start with here. That is 1, 2, 3, 4, 5, 6. Right. So we have a hex. So we have a hex and we have an in, right? So in at which position, beta? 4. So hex 4, e and ul, right? So this is hex 4 enal form. This is hex 4 enal form. Now let us write the substitute name. So in 2 we have a methyl group and 3 we have a keto group. So out of keto and methyl, right? So first of all you write K, है ना? So ये क्या हो जाएगा? 3 keto and this is 2 methyl, 2 methyl. So this is 3 keto, 2 methyl, hex 4 enal, right? This is hex 4 enal. So this is the correct name, right? That is the 3 keto, 2 methyl, hex 4 enal. So this is the correct name. So which option is correct, beta? That is 3 keto, 2 methyl, hex 4 enal. Yeah, that is option D. So option D is absolutely correct for. ठीक है, तो आ गया समझ सबको? ओके, शायद ये क्वेश्चन हम लोगों ने ऑलरेडी अभी अभी कर ही लिया है. इलेक्ट्रोफाइल कैन आइदर बी न्यूट्रल और पॉजिटिवली चार्ज, सो वी ऑलरेडी डिड दिस क्वेश्चन. नाउ द नेक्स्ट क्वेश्चन इज which of the following statement is not correct for a nucleophile, right? So you have to identify which of the following statement is not correct for the nucleophile. So first of all, ammonia is a nucleophile. चलो देखते हैं. So structure of ammonia is like this, and ammonia having the lone pair of electron. So if they having the lone pair of electron, then definitely they are the electron donor or they are called nucleophile. So this is the correct one, right? So this statement is correct. Now nucleophile attack low electron density site. ठीक है, तो ये बात भी सही है भाई कि न्यूक्लियोफाइल कहाँ अटैक करता है? लो इलेक्ट्रॉन डेंसिटी साइट, मतलब जहाँ पे इलेक्ट्रॉन की कमी होती है वहां पे न्यूक्लियोफाइल अटैक करता है, उनको इलेक्ट्रॉन प्रोवाइड करता है. ठीक है, तो ये स्टेटमेंट भी बिल्कुल सही है. न्यूक्लियोफाइल आर नॉट इलेक्ट्रॉन सीकिंग. बिल्कुल, ये इलेक्ट्रॉन डिफिशिएंट थोड़ी होता है, ये तो इलेक्ट्रॉन डोनेट कर रहा है, तो दे आर ऑल्सो नॉट इलेक्ट्रॉन सीकिंग. तो ये भी ट्रू है. बट इन दिस क्वेश्चन दे आर आस्किंग विच ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट. ठीक है, इसने पूछा है कि कौन सा स्टेटमेंट करेक्ट नहीं है न्यूक्लियोफाइल के लिए. ठीक है, सो विच ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट. सो भाई नॉट करेक्ट तो यही हुआ. अब डी ऑप्शन बचा है. कैसे? कि न्यूक्लियोफाइल इज अ लेविस एसिड. ये गलत है, बिकॉज न्यूक्लियोफाइल को हम क्या बोलते हैं? लेविस बेस. इसको हम क्या बोलते हैं बेटा? लेविस बेस, बिकॉज दे हैविंग टेंडेंसी टू डोनेट इलेक्ट्रॉन. तो इनके पास टेंडेंसी होती है इलेक्ट्रॉन को डोनेट करने की, इसीलिए दे आर कॉल्ड लेविस बेस, नॉट लेविस एसिड. सो जो डी ऑप्शन है ये इसके लिए ऑप्शन क्वेश्चन के लिए सही होगा, क्योंकि हमें पता करना था रॉन्ग स्टेटमेंट. सो विच ऑफ द फॉलोइंग इज द रॉन्ग? दैट इज ऑप्शन डी, कि न्यूक्लियोफाइल को हम लेविस एसिड बोल रहे हैं. न्यूक्लियोफाइल इज ऑलवेज कॉल्ड लेविस बेस, नॉट लेविस एसिड. क्लियर है ये चीज? चलो, now again in this question you need to calculate the total number of pi bond electron, right? You need to calculate the total number of pi bond electrons, कि भाई कितने pi bond electrons हैं इसमें. ठीक है, so we have a total number, we need to calculate total number of pi bond electrons. तो चलो देखते हैं फटाफट. So total number of pi bond कितने हैं पहले ये बताओ. So we have one pi bond here, we have second pi bond here, third pi bond here, and fourth pi bond here. So total number of pi bond we have 4. And in this question they're asking total number of pi bond electron. Not they're asking pi bond. They're asking total number of pi bond electron. So we can say that number of double bond. Number of double bonds. तो कितने number of double bonds हैं इधर? 4. So the number of double bond is equal to 4. Now number of pi bond electrons. ठीक है, So the number of total double bond is equal to 4. Number of pi bond electron is nothing but is equal to 2 into number ऑफ डबल बॉन्ड्स, है ना, क्योंकि एक डबल बॉन्ड में दो इलेक्ट्रॉन्स होते हैं, है ना. सो दिस इज डबल बॉन्ड, डबल बॉन्ड, है ना, 2 इंटू नंबर ऑफ डबल बॉन्ड्स. सो बस हो गया काम. सो दिस इज 2 इंटू 4, तो इट कम्स आउट टू बी 8. तो क्या होगा करेक्ट आंसर बेटा? 8. सो 8 इलेक्ट्रॉन्स इसमें होने वाले हैं. दैट इज द टोटल नंबर ऑफ पाई बॉन्ड इलेक्ट्रॉन इन द फॉलोइंग स्ट्रक्चर. सो दिस इज कम्स आउट टू बी 8. समझ आया सबको? इसमें हमें क्या, बच्चे कहाँ कंफ्यूज हो जाते हैं, पाई बॉन्ड बोल देते 4 है. सो इन दिस क्वेश्चन दे आर आस्किंग नंबर ऑफ पाई बॉन्ड इलेक्ट्रॉन्स. सो ऑलवेज रिमेंबर, in pi bond we have two electrons in a pi bond, right? So pi bond contain two, so total we have a four. Total we have the four double bond, so we can say that pi bond 2 into 4, that is 8. ठीक है, ये कंफ्यूज मत होना कभी भी कि जैसे कार्बन कार्बन डबल बॉन्ड है तो किसी ने बोला एक बॉन्ड में तो दो इलेक्ट्रॉन होते हैं, तो दो बॉन्ड में दो यानी चार इलेक्ट्रॉन होंगे डबल बॉन्ड के अंदर. तो मैं ये नहीं पूछ रहा, इसमें से पूछा पाई बॉन्ड के अंदर, इसलिए सिग्मा बॉन्ड को नहीं पूछा. तो अगर आपको पाई बॉन्ड का ही पूछा, अगर इसने पूछा पूछता कि टोटल नंबर ऑफ इलेक्ट्रॉन बताओ बिटवीन कार्बन डबल बॉन्ड कार्बन, देन आप बताते 4. पर यहाँ पे उसने पहले ही मेंशन किया है कि सिर्फ पाई बॉन्ड इलेक्ट्रॉन्स को बताना है. तो डबल बॉन्ड में तो एक ही पाई बॉन्ड है ना, और एक पाई बॉन्ड के अंदर कितने इलेक्ट्रॉन्स होंगे? दो होंगे. तो टोटल नंबर ऑफ इलेक्ट्रॉन कम्स आउट टू बी 8. ठीक है, 16 में कंफ्यूज मत हो जाना. चलो, अब नेक्स्ट क्वेश्चन है हम लोगों का, विच ऑफ द फॉलोइंग इज द मोस्ट करेक्ट इलेक्ट्रॉन डिस्प्लेसमेंट फ्रॉम अ न्यूक्लियोफाइल रिएक्शन टू टेक्स प्लेस. सबको बताना है इसमें से कि कौन सा करेक्ट एक्सप्लेनेशन है इसमें न्यूक्लियोफिलिक रिएक्शन टू बी टेक्स प्लेस. ठीक है, सो न्यूक्लियोफिलिक रिएक्शन टेक्स प्लेस के लिए कौन सा इसमें से करेक्ट है, बिल्कुल. तो ध्यान से देखो बेटा, मैं बनाता हूँ इस एक बार, इसको बनाते हैं, दैट इज CH3 and this is CH double bond CH CH2 and this is Cl. Done. So न्यूक्लियोफाइल का मतलब क्या होता है कि whenever some electron withdrawing group is attached to the carbon and when they release, जब वो electron withdrawing group निकलता है, so they produce positive charge on the carbon atom. So nucleophile come and support करता है उस positive charge को. ठीक है, सो कौन सा ऑप्शन करेक्ट होना चाहिए? जैसे ये देखो, ये है मेरा एक तरह का न्यूक्लियोफाइल CH3. लेट अस अज्यूम CH3 यहाँ पे इलेक्ट्रॉन को डोनेट कर रहा है. तो कर क्या रहा है ये, क्योंकि यहाँ से क्लोरीन इलेक्ट्रॉन को लेके जा रहा है. ठीक है, क्लोरीन इलेक्ट्रॉन को लेके जा रहा है, तो ये क्या करेगा, ये अपना पाई बॉन्ड यहाँ पे शिफ्ट कर देगा, पाई बॉन्ड यहाँ पे शिफ्ट कर देगा. तो क्या नेक्स्ट स्ट्रक्चर बन जाएगा इसका, बताओगे जरा? तो नेक्स्ट स्ट्रक्चर बनेगा इसका H3C. ये इसने डोनेट किया था CH, इसका डबल बॉन्ड जो था CH, क्योंकि यहाँ से एक इलेक्ट्रॉन चला गया, पॉजिटिव आ गया ना, यहाँ पे क्लोरीन निकल गया पहले स्टेप में. तो अब क्या होगा, ये यहाँ पे डोनेट कर देगा. ये क्या कर रहा है, डबल बॉन्ड अपना यहाँ पे नेक्स्ट वाले पे डोनेट कर रहा है, यहाँ पे. ठीक है, ये इस पे डोनेट कर रहा है. तो डोनेट किया तो क्या बन गया होगा भाई, ये बन गया होगा H3C, और यहाँ पे आ गया होगा पॉजिटिव चार्ज, यहाँ पे आ गया है पॉजिटिव चार्ज, और यहाँ पे बन गया होगा CH डबल बॉन्ड CH2. तो इस तरीके से, सो कौन सा करेक्ट रिप्रेजेंटेशन है, यानी पाई बॉन्ड इज ट्रांसफर आफ्टर लीविंग क्लोरीन, देन न्यूक्लियोफाइल विल अटैक अ स्टेबल कार्बोकैटायन. ठीक है, फिर न्यूक्लियोफाइल किस पे अटैक करता है, स्टेबल कार्बोकैटायन पे. यानी सबसे पहले क्या हुआ होगा, न्यूक्लियोफाइल यहाँ पे जो अपना लीविंग ग्रुप है दैट इज क्लोरीन, ये यहाँ से निकला. सो एज सून एज क्लोरीन विच इज अ लीविंग ग्रुप इज रिमूव, तो वहां पे हो जाएगा पॉजिटिव चार्ज इंट्रोड्यूस होगा, देन दिस डबल बॉन्ड, right, then pi bond is transferred after leaving chlorine, then nucleophile will attack to a stable carbocation. तो ये न्यूक्लियोफाइल एक स्टेबल जो सेकेंडरी कार्बोकैटायन है वहां पे ये अटैक कर रहा है. ठीक है, सो ए ऑप्शन इज एब्सोल्युटली करेक्ट फॉर दिस. कौन सा ऑप्शन करेक्ट है बेटा? ए. Now, move to the next question, that is arrange the following increasing order of their stability. So you have to arrange them according to their order of their stability. ठीक है, so फटाफट देखते हैं ऑर्डर ऑफ देयर स्टेबिलिटी पे इनको अरेंज करना है. तो कौन सबसे ज्यादा स्टेबल होने वाला है, कौन सबसे कम स्टेबल होने वाला है, ठीक। सो बस वही कॉन्सेप्ट है प्राइमरी सेकेंडरी और टर्सरी का, कौन सा कार्बोकैटायन है। तो अगर आप ध्यान से देखो, सो सेकेंड वन को देखो कैसे स्ट्रक्चर बनाओगे, सबका सबका बनाते हैं, ठीक है। सो दिस इज CH3, सी, CH3 पॉजिटिव चार्ज है, एंड दिस इज CH2 एंड CH3। डन। सो एक तो ये हो गया। नेक्स्ट जो डायग्राम है ये फर्स्ट वाले का है। नेक्स्ट सेकंड वाले का देखो, वी हैव अ CH3, C, CH3, अगेन वी हैव अ CH3। एक ये कार्बोकैटायन है। फिर क्या है हमारे पास थर्ड पे, CH3 है, C है, एक और CH3 है, और ये CH प्लस है। डन। फिर फोर्थ क्या है, फोर्थ है मेरा सिंपल सा CH3 और CH2 प्लस, और फिफ्थ में तो कुछ है ही नहीं, CH3, मिथाइल कार्बोकैटायन, ठीक है। Now, we all know that this carbocation stability depend upon the hyperconjugation. So here in this case, we have 9 alpha hydrogen, 9 alpha hydrogen, right? So sorry, here we have 9 alpha hydrogen. Here we have only 6 to 8 alpha hydrogen. Hmm? Here we have only 6 alpha hydrogen. Here we have only 3. Here we have no alpha hydrogen. So we can say that maximum stability for second, right? तो maximum stability किसकी है, second की है, या फिर फर्स्ट की है क्या? बिल्कुल, 8 अल्फा हाइड्रोजन है तो फर्स्ट, फिर 3 की है, क्योंकि 3 पे कितने हैं, 6, ठीक है, फिर फोर्थ एंड फिर फिफ्थ। तो कौन सा करेक्ट हुआ, ए। सो ऑप्शन ए इज एब्सोल्युटली करेक्ट, ठीक है। सो ऑप्शन ए इज एब्सोल्युटली करेक्ट फॉर दिस, ठीक है। So this is the correct order, or we say the increasing order of their stability, because we know that tertiary carbocation is much more stable as compared to the primary carbocation. And why this is? So this is basically as the more the number of alpha hydrogen, stability will be increased. ठीक है, तो stability उससे क्या हो जाती है, बढ़ जाती है। चलो, move to the next question बेटा, बताओ जल्दी। What is the hybridization state of benzyl carbonium ion? So in this they are asking what is the hybridization state of benzyl carbonium ion, ठीक है। So benzyl carbonium ion का hybridization state बता दो, ठीक है। So what is the hybridization state of benzyl carbonium ion? So here we have we need to find the hybridization of this carbon atom. So for this we know that this carbon is attached to two hydrogen and with the benzene ring, ठीक है। सो अगेन हाइब्रिडाइजेशन इज नथिंग बट नंबर ऑफ सिग्मा बॉन्ड प्लस लोन पेयर ऑफ इलेक्ट्रॉन्स, so number of sigma bond plus lone pair of electrons. So here we have 1, 2 and 3, only 3 sigma bond and 0 lone pair of electrons, so the hybridization comes out to be sp2. So क्या है hybridization बेटा, sp2. So option E is absolutely correct, ठीक है। सो आई होप सबको समझ आ गया होगा यहाँ तक। एनी वन हैविंग एनी काइंड ऑफ डाउट यू कैन आस्क बेटा, किसी को भी कोई भी डाउट हो, अभी तक हमने जितने भी क्वेश्चन सॉल्व किए हैं उसमें से किसी को कोई भी डाउट हो तो यू कैन आस्क, ठीक है। नहीं है, क्लियर है सबको? डन। सो दिस इज ऑल अबाउट। नेक्स्ट क्वेश्चन एक है उसको देख लेते हैं फटाफट कि नेक्स्ट क्वेश्चन क्या बोल रहा है हम लोगों से। सो नेक्स्ट क्वेश्चन है हमारे पास, वो ये कह रहा है हम लोगों को कि वी हैव अ टू स्टेटमेंट दैट इज द ट्रोपेनोन इज एन एरोमेटिक कंपाउंड, ठीक है। ट्रोपोलेन इज एन एरोमेटिक कंपाउंड एंड हैज 8 पाई इलेक्ट्रॉन्स, एंड स्टेटमेंट 2 ये कह रहा है कि पाई इलेक्ट्रॉन्स ऑफ कार्बोनिल ग्रुप इज ट्रोपोलोन इज इन्वॉल्व इन एरोमेटिसिटी। सो क्या है, स्टेटमेंट ट्रू है, कौन सा स्टेटमेंट फॉल्स है, आपको ये बताना है। सो सबसे पहले मैं बताऊं तुम्हें तो एक चीज याद रखो, दैट इज ट्रोपेलोन इज एन एरोमेटिक कंपाउंड, राइट। ट्रोपेलोन इज एन एरोमेटिक कंपाउंड एंड इट कंटेन अ 7 मेंबर रिंग विद द 6 कार्बन एटम एंड 1 ऑक्सीजन एटम, ठीक है। तो 7 मेंबर रिंग होता है एंड इट कंसिस्ट ऑफ seven-member ring and with a six carbon and one oxygen atom. So the oxygen atom is doubly bonded to one of the carbon atom, forming a carbonyl group. So the statement one, that is absolutely correct. Right, statement one state that tropodone is an aromatic compound and it has a 8 pi electron system. But statement two, that is a pi electron of carbonyl group in tropodone is involved in aromaticity. Right, so this is not the correct one. So the correct statement is statement one is true, but the statement two is not a true statement. Now, next is write the IUPAC name of the following compound. So you just need to write the IUPAC name of this following compound. What is the IUPAC? Right. So in this, we have two functional group, that is COH and ketonic functional group. So out of these, you need to find the correct one, right? So we start numbering from here, that is 1 2, because we give priority to carboxylic acid. So 1 2, and this is 3, this is 4, this is 5, and this is 6 we have, right? This is 6 we have. So we know this is a hexanoic, right? Yeah, this one is a hexanoic. So this is hexane and oic acid. So this is hexanoic acid. Okay. So this is hexanoic acid, and we have a keto group and a methyl group. So at which point, no, numbering is like this now. This is 1 2 3, not this. Sorry. 1 2, because we give priority to the functional group. So we have a 2 methyl. So 2 we have a methyl. So that is 2 methyl. So 2 methyl, and 5 we have oxo, because whenever ketone is used as a substitute, we name it oxo. So the correct name is 2 methyl 5 oxoanoic acid. Okay. So this is the correct way. That is a 2 methyl 5 oxohexanoic acid. So I hope this is clear to everyone. सबको clear हो गया होगा ये, that how will you find the name and particular things like this. ठीक है. So this is the way to name the UPC nomenclature of this compound. ठीक है. So thank you all. This is all in today class. In the next class also we are going to solve some question related to this GOC. Thank you all.